How's it going? Hope everyone's doing well. Do you all have a test coming up in your other class? The 1324 class? Okay. Are y'all into chapter 5 yet, or are you still working on chapter 8 and 9? Hmm. Okay. I was just curious. Are there any questions on anything from the other class or this class that y'all want to go over first? Hope you all enjoyed the Monday off. Um, I know I did. And the weather is nice for sleeping this morning, so I appreciate everyone joining us today. So, do you all have any questions on the chapter 8 material, or doing okay so far? Okay. I just uploaded a file to Canvas. If you look in the Files section, it's called Calculator Skills. I'll go ahead and put it on screen. Assuming this works. Sorry. So, luckily I have it on my computer. And the idea of this worksheet is, and this is just something we wanted to work on prior to starting Chapter 5, which we're a little bit ahead of that. But I went ahead and uploaded it so we can start working on it. And actually, it has the answer. It's like the first couple of pages are the worksheet itself, and the following pages beyond that are just the answers. So you have the answers already. The main thing we want to be able to do is use our calculator effectively in the ways described in this worksheet. I'm talking to the camera, but I forgot the camera is not displayed. There we go. So this is the worksheet that we're looking at. And what I wanted to do is go through, now work maybe one of each of these types of problems and then allow you to practice on the others. Okay. And well, I'll work a similar example. Now, the first couple of sets of problems are on fractions, and so you can see 1 through 4, it's all on reducing and simplifying fractions using our calculator. Again, we don't want to have to necessarily do this by hand. The goal is to be able to use the calculator to do all of this now. And then again, working on operations with fractions, add, subtract, multiply, divide, and 5 through 8. Working with mixed numbers on again, add, subtract, multiply, and divide, mixed numbers. And then using the Ans key, the answer key on your calculator. Listing the factors of different numbers. And so on. And here with exponents, just plugging in numbers and calculating values of exponents. So these are things that we've talked about already, but now we also want to be able to use our calculators to do these things, because when we get into Chapter 5, especially with the formulas that we're working on there, it's going to be very important that we're able to use our calculator to find those values and not let that be the step that bogs us down. By fully understanding what the calculator allows us to do and how to utilize it, we're able to better spend our time working on the actual concepts and not worrying about how the calculator is going to do this. Okay. Anyway, so there's 34 questions here, and then you see the key follows, and it has all the answers in red. Honestly, I couldn't figure out how to split up this PDF since I don't have any PDF software on my home computer, and I don't want to mess with it, to be honest. So you get both the problems and the answers, which is fine. The main thing I want us to work on now is making sure we're able to get those same answers in practice with our calculators. Okay. So, I'm going to use, let's see, I have my TI 36X. No, this is just for you all to practice, since you have the answers already in the same document. So don't worry about turning it in. Yeah, there's no way I can really do that without, no. Sorry. There's no way I can have y'all turn that in without just giving everyone 100. I guess we could do that, but, Yeah, I would recommend a scientific calculator, especially because of the exponent function. You tend to not have that on the more basic calculators. So I think for business math, I don't know if Mrs. Knisley had you get a specific calculator. You frequently see, like, I think it's the TI 30s are what we normally recommend for business math. I like the 36 because if we have to take a statistics course, it also works for statistics and calculus and everything else that we offer. That's my take on it. So the latest on homework for this class is don't worry about it yet, because I don't know, to be honest. I just don't know. Now, regardless of what kind of calculator we have, ideally you have some kind of button that allows us to enter fractions into the calculator. For instance, on this calculator, you have like a little box over another little box. This kind of simulates an image of a fraction right here. So let me make sure I'm on camera. Yes. Okay. I still have the worksheet on my screen. So this button here will allow us to enter fractions. For instance, if we wanted to enter 7 over 9, we press the 7 first, and then the fraction button, and then 9, and so that gives us 7/9. If we just press enter, it doesn't have anything to reduce, so it just gives us 7 over 9. Now, if we do have a fraction that we could reduce, let's say we have 1,000 over 825. Okay. Now this one, because the numerator is larger than the denominator, we know that this will also create a mixed number because there's going to be a whole number component as well as a fractional component that should need to be reduced based on looking at these two numbers. Again, the nice thing here is that it gives us 40 over 33. Oops. It just keeps giving us that. Okay. I wonder if there's a way to make it a mixed number. So if we do 40 over 33, no. I'm just going to leave it as mixed number. If we do that math print business, it might. No, math print is that thing. Never mind. We want that off. Sorry. Anyway, so the fraction button again on this calculator, you just have this two boxes written kind of like a fraction. My other calculator here has this A, B over C button. And that might actually do it a little bit better as far as what I'm wanting us to try there. Like on this calculator, if I enter in 1,000 over 825, it actually goes ahead and makes it a mixed number, which is nice. and this is my sharp. And I actually prefer this calculator, but the other one's probably a little bit better for a lot of things. Anyway. So we can see that by entering the fraction button, it took 1,000 over 825 and turned into 1 7/33. Okay. That's fine, James. Okay, so the first 4 problems on that worksheet are just working with the fractions. Now, if you have a calculator like this other one where I entered a fraction, for instance, and got a 40 over 33, and we wanted to make that a mixed number instead. I don't know what I would recommend necessarily. That's a good question. Like I said, the TI-30, TI-36, those are very general models of calculator that work for a lot of different things. If you know that you need to take some kind of statistics course, I would recommend the 36 because it does have the statistics functions built in as well. The 30s tend to have more business operations built in. So I know a lot of you are majoring in business. That might be a good option there. The nice thing is that they're relatively cheap. They're all kind of in the $20 range, I think, 20 to 30, as opposed to like a larger graphing calculator where it may be $100. Not that there's anything wrong with the graphing calculator. I just don't want you to spend $100 on a calculator if you don't have to, especially. So yeah, something like 36 or the 30, I would be fine with that. If Mrs. Knisley hasn't recommended anything and you don't have one yet, those would be my recommendations. Yeah, and it depends largely on where you plan to go from here, because I don't want you to have to buy like 5 different calculators for different things. I use 2 different calculators for statistics because it really depends on which ones my students buy. The cheaper scientific versus the more expensive graphing calculator. But then I still have my own favorite calculator that I like. I feel is more easy to use, which is the Sharp. And I use that all the way back to when I was in college. The Sharp models, because of the way that I've always preferred the way that you enter commands on this versus like the TIs. But anyway, I think that just comes down to personal preference. And if you're at a point in your life where you have a personal preference among calculators, then you're some kind of nerd, or some kind of math nerd in this case. So. But I fully accept it. So. These are, I uploaded them to Canvas, and let me go back there. This is our course in Canvas, and I put them just in the files here. So if you click on files, it has all these documents here. These are the syllabus files that we already looked at, and then now they have the calculator skills file, which finally decided to open on my computer, so that's good. Okay, so in 1, 2, 3, and 4, we're just working on the fractions. Now, Sure, good. One thing I mentioned is that not only do we want to reduce these fractions, we want to be able to write them as mixed numbers. So in this scenario, where we're able to reduce 1,000 over 825 to 40 over 33, that's fine, but I mean that's an improper fraction, but we still need to make that a mixed number. So 40 over 33, if we want to make that a mixed number, then the idea is that we want to take 40 and divide by 33. So we think about how many 33s are there in 40, now that it's reduced. Well, there's only one 33 in 40. 1 times 33 is 33, and then we subtract and leave 7 as a remainder, so that is 1 and 7 over 33. Okay. And so for a calculator such as this that will put it in reduced form but not actually change it to a mixed number, that's the next step that we would need. My other calculator actually goes all the way and just takes the 1,000 over 825 and goes all the way and just makes an improper or a mixed number. It skips the improper fraction step. But you can easily put it into an improper fraction on this calculator, going back and forth. Again, another reason I like this one, just for personal use. So. All right. So each of those first 4 problems are going to be like this, where you just want to reduce the fraction and then simplify from there. If it does happen to be improper, where the numerator is larger than the denominator, then we want to go ahead and express it as a mixed number. Now, Now the next set of problems on the worksheet are operations with fractions, which means we want to be able to add, subtract, multiply, and divide fractions on our calculator. So, for instance, if we want to find 2/5 plus 4 over 9, notice that they don't have a common denominator, but the calculators actually sort out what the common denominator is and successfully combine the 2 fractions into a single number. Okay. For those of you that have usable calculators for this class already, have you found the button that allows you to enter fractions? That's good. It used to be that not all calculators had those, but I think by now most of them do, if not all. Oh, good. Yeah, so it actually looks like what it is here in my other calculator, where it says A, B over C. Good. That's interesting. All right. Does it actually reduce it on the 30s? Like, well, I know it reduces. Sorry. Does it actually take it from like a improper fraction and make it a mixed number? Yeah, it did for okay. That's good. And if it's like mine over here, if you look right above the A B over C button, there's a D over C. That's for when you have a mixed number and you want to make it improper. So you press second, and then D over C, and it makes it 40 over 33. If you want to switch back, then you do second and then D over C again, and it moves it back to a mixed number. Okay. So it may or may not have that feature as well. Okay. If we want to subtract fractions, it's exactly the same process. We just do minus instead of plus. So if we did 4 over 5 minus 8 over 31, we combine and we get our answer, the 84 over 155. Yeah, that's a handy one. Definitely recommend that where it's necessary. I mean, it's not essential in the grand scheme of things, but it's nice, you know. If we were to do 7 over 16 times 8 over 9, we can easily multiply fractions. And if we did 4 over 7 divided by 5 over 21, again we can do our division. So with our 4 basic operations on the calculator, we're still able to use those with fractions just like normal numbers. And you know, we're gonna, you know, it should be pretty easy going through that worksheet. Now, the other thing that comes up on, well, the next part on the worksheet is basically the same thing, but with mixed numbers instead of just normal fractions like we were working with here. So the difference is if we're working with mixed numbers, let me go ahead and clear that, is we can say 1 and 2 fifths, which you didn't like that. See, my other one works that way. I don't know about this one. Aha. So in this calculator, here's our mixed fraction button, which is right above my 7 key, and then my regular fraction button. So the looks like an underscore mark here means 1 and then we'd use our normal fraction button here. So like for this calculator, I would say 2 and 5/8, for instance, and it goes ahead and changes it to 21/8. Or I could actually go through and do an addition or a subtraction. So if we said 3 and 1 over 9 minus 2 and 4 over 13, it'll give us the result still. It's a little bit easier, I think, on this calculator, because I would just go 3 and 1 over 9, just using the same AB over C button both times, minus 2 and 4 over 13, and we get the same result. So hopefully between the two of those, either one or the other will work for you. Okay. So our mixed numbers, besides the extra step in some calculators and how we enter that mixed portion, it works really the same as what we did with the fractions, which is we enter the numbers and then we just use the whatever operation we need in between. In this case I did minus. Okay. So we talked about these first three sections of problems now on fractions, mixed numbers, fractions, operations on fractions, and then operations on mixed numbers. Note that we do want to write each number as a mixed number and as an improper fraction or as a simplified fraction, which the calculator should actually simplify it for us, so it's not strictly a concern there. Next thing we want to look at is using the Ans key. Now, the Ans key on this calculator, and let me switch back because I'm trying to show you something. Calculator. Did I turn the light off? No. Okay. On this calculator, I'm zoom in a little bit there. It says right above the minus key here, it says answer. And so what that answer stores is the most recently arrived at solution. It just stores whatever we entered last, like with the enter button. Whatever answer we got from there is stored in this location. Okay. And same thing on this calculator, except it's ANS, which is a little bit more commonly seen. It just varies from one calculator to another. This one, notice there are different colors of buttons above the equal sign. So I have to press second for one color and then alpha for the other color. So in this calculator, I would press alpha and then the equal sign to access the ANS value, which for whatever reason is 7 on this one, or 0, sorry. This one, because we only have one row above the buttons, we just have to press second and then answer and press enter, and that'll give us the most recently calculated answer. Okay, the reason that's handy is we can actually use that in our calculations. So let me zoom back out there. So and if we look at the instructions on the worksheet, it has to perform one operation and then use the answer from that in the next operation and use that answer in the following operation and so on. It just takes our result and then continues to use it in the next parts of the problem. So if we wanted to calculate something first, let's say we did you're not seeing that ANS button? Usually it's above one of these buttons down here. It says answer or ANS. Nothing like that? So right above our negative button, we have an answer here. Only know the multi-line calculator. Oh. And ANS here. That kind of makes sense when you say multi-line. Like even my graphing calculator has that ANS button right above the negative sign, which I guess is standard for the TIs. Well, all that means is it makes it a little bit more difficult for y'all to do that problem. You can just write down your answer at each step and then include it in the next portion. Let me see if I can create a similar problem to what's on the worksheet, just to give you an idea of what we're trying to do there. So we first want to do a calculation. The store kind of does that. Store is kind of wonky to use, I think. I would not recommend that. Answer is like the easier, faster version of that. ANS. I would not recommend store. It's in Canvas and Files, Jarek. Okay. So this set of problems here basically mirrors what we see on our worksheet. So they want us to calculate this value first on our calculator, and then just keep that answer stored there and use it as part of the next operation. Now, for those of you that do not have the Ans key or anything similar to that, I would just write down your answer at each step so you can just put it back into the calculator. It is a bit of a time saver, but it's also not the end-all be-all, so don't worry too much if you don't have that. Oh, I was using the other one. Sorry. There we go. So we start off, we do our square root of 7 squared minus 3 cubed. So we have to identify where a square root button is, which turn it on first. Now, on this calculator, the square root button is actually right above the x squared button that's right here. So I have to press second and square root. Then we want to enter 7 squared minus 3 to the third. Now, So when I want 7 squared, I just put the 7 and I hit the x squared button. And then minus, and then I put 3. Now if I want cube, unlike x squared, there's not really an x cube button. Some calculators may actually have an x cube button, but a lot don't. And instead, we needed to raise it to a power. So I press 3, and then here's the power button, like to raise it to a power, and then I press 3 again. And the other thing we notice is that when on this calculator I press square root, it opens a parentheses. And so after I entered the expression, I close the parentheses, and it gives me the value. Okay? Part of the reason that we look at this worksheet in the first place is to get some practice using our calculator and finding where these different things are on our calculator before we need to use it in the other class. That's a larger issue that we're addressing here. It's just being comfortable with our calculator before we actually need to put it to serious use doing the calculations in chapter 5 for the other course. Now, not all calculators will open up parentheses here. For instance, on this calculator, if I enter the square root, it does not open up parentheses. So that's why we have the parentheses buttons here. So we would do 7 squared minus 3, and I actually have a cube button on this calculator. And then I close parentheses at the end, and it gives me the result, which should be identical if everything has gone properly. I would strongly recommend the parentheses. If we don't do the parentheses, it may not calculate it right. It just depends on how your particular calculator functions. But without the parentheses, there's no guarantee it will do it correctly. So I think it's a good practice to get into, is learning how to use those parentheses also. So by default, the TIs tend to open up parentheses when you press like a square root or similar operations, whereas like my other calculator here does not, so I have to do it myself. I press the open parentheses, enter the expression, and then close parentheses. The reason we use parentheses is to kind of control what does that square root affect. This time, because we want the entire expression under the square root, there's an implied parentheses around those things. And so when we want the calculator to do it correctly, we want to make sure that's in parentheses, because notice on this calculator, I don't know if mine will do it. If I do 7 squared minus 3 cubed, notice it did something different this time without the parentheses. I left out the parentheses, so what the calculator thought I wanted it to do, it thought I said, okay, take the square root of 7 squared, which is 7, and then subtract 3 cubed, 27, and it gives us negative 20. It only took the square root of the first part. It did the subtraction after the square root was resolved. So in order to keep it, doing the order of operations correctly, we want to work what's inside first. So we put that in parentheses. We want it to complete this operation first and then take the square root of that result. That's what the parentheses tells it to do. Does that make sense? Okay. So we get our result. Now, right now, this number is stored in the ANS button. But once we hit enter, did it just turn off? It just turned off, sorry. Once we hit enter, it saves whatever answer we get in the ANS, or answer. So, next step, I want to do 10 divided by this answer that we just got. So I'll enter 10, and then divide, and I want to press answer down here. So I'll press second and then the answer button. So it does 10 divided by ANS. Now, it's going to basically take this number that we got before and put it here where ANS is. Then we press equals, and that gives us our next result. So this is our answer to this part B. So A is just 4.69. And you'll notice the instructions in the worksheet what they want us to round to the nearest hundredth. So this would be 2.13. So hundredth is 2 places after the decimal. And so I'm putting the curvy equal sign because it's approximate. It's not exactly equal. Okay. So, part C, we want the square root of ANS, so we enter square root and ANS, and again on this calculator, because it opens parentheses when we hit the square root button, I went ahead and closed parentheses. Enter. So that's 1.46 about. Okay, now this is stored in our answer at the moment. So we want, finally, 126 minus our answer squared. And that gives us 123.87, it looks like. Okay, are there any questions on that? Again, it's vital that we practice this because we want to be comfortable with these concepts before we need to apply them. When you get into chapter 5, we have a lot of formulas in that chapter, and there's really 2 concerns in chapter 5. One is figuring out, okay, which number gets plugged in for which variable. Like, is this the interest rate? Is this the number of years that have passed? Is this the monthly payment? And so on. We get the numbers plugged in properly, and the other part of that is then calculating the result properly on our calculators, and that's what kind of thing that we're looking at here. The skills that we're developing here in this worksheet are what's going to help us be better prepared for that part of those problems. Okay, so that kind of mimics what happens on these 4 problems on the worksheet, 13 through 16. Let's move on to the factoring problems, and it gives us a lot of spaces. You don't necessarily end up having to use all of these spaces, but they want us to use the calculator to help us factor these things. Okay. So let me come up with a number, and I want to pick a relatively large number. Let's try Let's try 162. It may not be that interesting. We'll see. Now for 162, we know certainly that the first set of factors is 1 times 162. Now, 162 is an even number. That means we can divide it by 2. So it's 2 times 81. Does anyone know how we can tell if a number is divisible by 3 before using the calculator? I mean, we know in this case we can divide by 3 and it actually gives us an answer, 54. Does anyone know the shortcut off the top of their head? Well, the way that we can actually do that is that, like in the case of 162, if we add up the 3 digits there, 1 plus 6 plus 2, the 1 plus 6 is 7, plus 2 more makes 9. So the fact that we get a sum of 9 of those digits, because that's a multiple of 3, that means the original number is a multiple of 3 also. We know if it ends in an even number is divisible by 2, we know it's a multiple of 3 because the numbers add up to a multiple of 3. And actually 9 has the same rule. Since it adds up to 9, that means 9 is going to be a factor of this also. Now, again, we're not really going to rely on that because what we're going to do is try to divide it by 3. Now, if we took a number like 160 and divided it by 3 and it came out with this crazy decimal, okay, we know that's not a factor. But because we were able to get 162 divided by 3 gives us 54, we can write that down as a pair of factors then. If we try 162 divided by 4, notice that it does not come out to be exactly a whole number, so 4 is not a factor. By looking at 162, is 5 a factor? How do we recognize if 5 is a factor of a number? I mean, clearly 5 is not a factor of this number. But if our number ends in a 5 or a 0, then 5 must be a factor. Exactly. 6, the only way we can check for 6 being a factor is if 2 and 3 are both factors, which is actually true in this case, so we should have 6 being a factor as well. We can double check what number that actually is. Turns out to be 6 times 27. It's unlikely that 7 works, but let's try it anyway. Yeah, 8 probably doesn't work. Since 4 didn't work, 8's definitely not going to work. I don't know why I'm checking it, but there you go. 9 should work. So we talked about the rule for 9 is that the digits add up to 9, which is a multiple of 9. Technically it's 9 times 1. Okay. Now, we got it down to 9 and 18, so the question is, are there any other numbers in between where it could work? It might be 12. Let's try 12. Not 12. No. So we know it's not 10, it's not 11, it's not 12, probably not 13, and probably not 14. If it didn't work for 7, it's not going to work for 14 either. So that's all of our factors then for 162. Now, you could keep going and say, okay, well, 9 and then 18 would be the next one, but 18 we know is already paired with 9. So once we get these as close together as possible, we can stop. Okay. Unless there's another pair of numbers between these two that works, then we know that we've finished our factorization. There's actually a pattern for seeing if something is a multiple of 11, and it's a little bit strange. Pretty strange. So if we had the number 800 and 55,680. If we add every other term here, 8 plus 5 plus 8, that equals 21. And if we add if we add every other number here, 5 and 6 is 0, is 11. Then we look at the difference between these two numbers. If the difference is 0 or 11 or a multiple of 11, then the whole number is a multiple of 11. Now, I would actually need to change that to a 9 to get that to be a 22. So 955, 680 should be a multiple of 11. Which it is. 86,880 times 11. So that one's obscure, so I don't know, I'm just showing you random things at this point, so don't worry about that one. The main thing is on our factorization, we want to keep going with these numbers until these two numbers are as close as possible, because after 9, we could say 18 times 9 and write that down, but we already have written down just in the opposite order, so there's no need to write it again. So unless there's no more numbers between these two that work, then that's all we have. And so they have us do that twice on the worksheet. Okay. Now this next page is kind of more like working with formulas, where they give us the expression with letters and they want us to plug in what the letters are equal to. Now we haven't really talked about this, but let's see what we can do with some similar examples. Flip that over. And so you can see on 19 through 22, basically we have these values a, b, c, and d multiplied together with exponents in different ways in each of these examples. So for our part, let's see. I'll just make up an example for us. So let's find, let's say a squared b cubed c to the minus 1, where and I think they're using fractions for at least some of these. So we'll say a equals 2 over 5, b equals negative 3, and c is equal to 7 over 3. Okay, and again, we want to make sure we use our calculator for this because this is a pretty crazy problem if we tried to do it by hand. It's not a great arrangement here. Sorry. That might be good. Okay. So I want to do 2/5 squared first. Now notice I wrote parentheses 2 over 5 and then square, because we want to square both parts of the fraction, not just one or the other part. Whenever we enter a fraction, and that fraction is raised to an exponent, it actually depends on the calculator. Some calculators do it naturally, other calculators may only do one part but not both parts. I would say to err on the side of caution and just go ahead and put the number in parentheses before we raise it to a power. Okay. So times, because when we see these next to each other, that implies that we're multiplying them together. So we have a squared times b cubed times c to the minus 1 power. So b to the third, that would be, we said negative 3, close parentheses, raised to the negative third. That's a 5. That's my bad. Okay. At least on this calculator, I can arrow back and forth, and you can kind of see the different elements of this. So 2/5 squared, negative 3 to the. I don't know why I said negative third. Let me we just wanted that to the third power. I'm sorry. Because we plug in negative 3 for b, but then this raises to the positive third power. And then times. And then we have c, which is 7 over 3. And that one is raised to the negative 1 power. Finally, we press enter, and it gives us our result. Okay. So again, going across. We did 2/5 to the second power times -3 to the third power times 7/3 to the -1 power. Excuse me. Now, ideally, we're doing this all in one operation on the calculator, like we did this, like all 3 steps together, and then just hit enter one time. If you're not sure, or if you're not positive that you've got the correct answer, then you can find a squared, you can find b cubed, and we can find c to the -1. Get those individual results, and then multiply them together. That may help you see a little bit better where the answer is coming from. But we do try to do it all in one go, basically. Are there any questions on that? Okay. So our next set of problems, they want us to plug whole number values into formulas. So we might have different values for A, B, C, and D. Let's say A is 5, B is -10, and C is 1. Let's say 21 there. Okay. So let's find, first of all, -b over 2a. This is a formula that we sometimes use in equations of certain things. If b is negative already, then what would -b be? And that's part of it, Mary, is just being able to practice with the calculator and trying to get the same answers. Now, if you do have a specific question, please email me and let me know, or we can spend some time now and go over it or whatever. Yeah, it'll be end up being a +10, and then 2 times 5 on the bottom. We can plug that in, that'll be a 10 as well, and then we just do 10 divided by 10. We don't really need a calculator for that, that'll just be a 1. Okay. Second problem, let's try A times C over B plus 5A. Okay. So again, we plug in the values. We know that we're going to have 5 times 21 on top, A times C, and then B is negative 10 plus 5 times A, which itself is 5. Okay. So we get everything plugged in properly. Now we can go to the calculator and do our calculation. So we'll do... Now I'm going to use parentheses again for the numerator and the denominator separately. 5 times 21 in the numerator, divide, and then in the denominator we have negative 10 plus 5 times 5, and finally we press equals. Now I was hoping this would happen. Normally it gives us a syntax error because this, and actually it highlights it on this calculator, which is great. I did a minus, a subtraction sign here. So when you use the subtraction button on the calculator, a lot of calculators get real picky if you use the subtraction button when in fact you want something to be a negative. Okay? So this button is what we use to make a negative. This is actually the subtraction operation. And for whatever reason, the calculator distinguishes the two as completely different things and doesn't want us to mix them up. So instead of putting the subtraction sign, we actually just want a minus sign there. So I can just type in a minus sign and press enter again, and it actually calculates the value for us, rather than giving us an error. Yeah, sorry, I just saw that, Brent. So on some calculators, it's perfectly fine if you enter a minus sign as a negative. Other calculators is very picky, and that's why I was hoping it would happen on this calculator, because I think my other one is okay, a little more cool with that. So I know that TI calculators in particular don't want us mixing up the minus signs and the negative signs. So when we say minus 10, we actually mean a negative 10. We should enter in the minus, the negative button on the bottom rather than the subtraction button. Okay. So 3, let's do one more. And you might recognize this one. And rather than plus minus, I'm just going to choose the plus portion. And you can see a very similar problem on the worksheet, where it just has basically the quadratic formula, but just the plus, not the minus. Okay. So we know we're going to plug in negative b, which, again, if b is negative 10 to begin with, then the opposite of negative 10 would turn that into a positive 10. Then we have b squared, which is negative 10 squared, minus 4 times a times c. And then 2 times a on the bottom. So here we're just plugging in the numbers. Now, something else is going to happen this time that I forgot about when I was making up the numbers. So I apologize in advance for that. Yeah, that's the whole thing. What we'll find happens in this case is the calculator is just going to give up with this number under the square root. Let's look at that number in particular. We won't even worry about the 10 or the 2 times 5 on the bottom. Let's just work at this square root portion, just to show what happens there. So we do our square root, and we want a negative 10 squared minus 4 times 5 times 21. Now, one of the things that you'll notice is that I opened two parentheses because I went ahead and put the negative 10 in parentheses squared, and there was another parentheses outside of that. So now we have nested parentheses that we're using. And then we have minus 4 times 5 times 21. Now, some calculators all of them are going to give you some kind of error here, because what actually happens is that we end up taking the square root of a negative number in this case. So this is 100, negative 10 squared. 4 times 5 is 20 times 21 is actually 420. So 100 minus 420 is negative 320. We take that square root and it's just not a real number anymore. That's what we'd call an imaginary number. We haven't talked about that yet, or I don't know if we will, but that's what the square root of a negative amounts to. And so if we try to enter this into our calculator, then we should expect something like that. A domain error or syntax error, or some kind of error message, basically. I think on mine, other one, if we just do square root of negative number, it just says error. Yeah, it does specify, but yeah, that's what it means. So instead of 21, let's use just a 2. Okay. So if we use 2 instead of 21, and we go back and we repeat this, I can just delete the 1. That's actually kind of nice. And yeah, then we get our answer, and it gives us a result, actually. Okay. The next set of problems on the worksheet deal with what are basically geometric formulas, and they want us to be able to plug in numbers and evaluate those. So if we had said, for instance, volume, and this is for a cone, is 1/3 pi times r squared times h. And we're told that the r, the radius, is 6 centimeters, and the height, h, is, let's say it's 10 centimeters high. And we want to plug that in. Sorry. Well, we know that we're going to do 1/3 times pi times r, which is 6 squared, times h, which is 10. Okay, we know that we have to multiply all those together. But in this particular example, we're looking for a pi button on our calculator, because otherwise we'll actually have to enter an approximation for pi. Now, this calculator, pi button is very prominent. We can just see pi right there. Okay? And I would just press that button to get pi, which is approximate to 3.14159, etc. Okay? Other calculators have it a little bit more hidden, such as this one. We don't strictly have a pi button here, but notice over here it says pi, e, and I. So if I press that, it gives us pi. If I press that button again, it gives us e. And if I press that button one more time, it gives us I. The fourth press should be back to pi again. There we go. Okay. So this one, because we have multiple functions on the same button, if we press the button again, then it gives us the next one, then the next one. Same thing like with our trig functions, but we don't have to worry about those. Okay. So we wanted 1/3, so we have a fraction 1/3 times pi times 6 squared times 10. Now, depending on your calculator, at this point mine's giving me 120 pi. Unfortunately, it doesn't want to not give me 120 pi. Now, so we can say our volume in this case is equal to 120 times pi, but we may also want to approximate that answer. And, it's not a mode issue. How would we approximate that? Well, I mean, at worst, we can just plug in 3.14159 for pi. So we can get our approximate answer that way. We know it's 376.99. Other calculators, like this one, if I entered in 1/3 times pi times 6 squared times 10, this one will actually give us the approximation, which is the same, 376.99. So it's the same approximation, but we didn't have to work for it at all. So part of it's how your particular calculator functions, working with the pi button in particular, whether it actually approximates it out or just leaves as part of the answer. We can work with it either way, but preferably it actually gives us a decimal value like we have here. I'll be honest, I don't know where she's getting some of these. I don't know which calculator she has that's doing all these functions that she has in here. Anyway. Moving on. So we talked about entering values like R, B, and H into these formulas. We want to give the answer as decimals nearest hundredths, so that's what we were doing there. So the next set is correcting without re-entering, which this one says second and enter, but that really only applies to certain calculators. I don't think it applies to either one of the calculators that I have, although I may be mistaken. Yeah, it doesn't work there, and then it absolutely does not work here. In fact, on my Sharp calculator, let me switch back. On this calculator, if I hit second and equals, it actually changes it to a base 5 number, because this one has different bases available: base 16, base 2, base 10, base 8, and base 5. So yeah, we will not be able to follow that instruction. Now, if we have a multi-line calculator, the question is, how can we go back and edit something, basically? Like if we had set a square root of, let's say, 8 squared plus 4 to the third, we can get an answer that way. What if we want to go back and change that plus to a minus? Now, the page there is saying we can hit second and equals or second and enter. Again, that's completely dependent on your calculator, and I don't know that this one still has the same function. On mine, at least, this one, if I press the right button, so we get our last, well, no, that's not our last answer, my bad, sorry. So if we go through and say, once again, the square root of 8 squared minus 4 to the third, and we get our answer 0. If I press the right button, I can arrow over and change that minus to a plus, delete the minus sign, and then get a different answer that way. Okay. On this one, not quite sure how that's going to work, but we'll try it. If we do, let's say, 8 squared minus 4 to the third, comes out to be 0. If we arrow right, doesn't do anything. Left, up. So yeah, this one I'm not even sure we can even do that. So it mentions it in the work there, but if it's not something that applies to your calculator, then don't worry about it. Now, same thing is true about this table set function. This is something we frequently see on, again, multi-line displays. I wonder if I can even do it on either of these two. I know I can do it on the graphing calculator, because that's a different thing entirely. It doesn't appear to be something I can do there. Now, are we looking at this? Yeah, we're looking at this. Sorry. The idea here is that we're given a function f of x equals square root of 3x squared minus 17. And we want the calculator to enter in all these different values for x and calculate the function value here, which is a nice idea. Let me make up an example for us. I'll let f of x equal square root of x squared plus 5 and I'll pick some numbers for us. 0, 10, 100, 1000. Okay. Alright. Now, here they want us to try to use the table set function. Well, at least on my graphing calculator, that's a feature. As you can see, right here it says table set. Okay. That's not something we tend to have in a lot of our other calculators, so I don't know about the necessity of that. I don't see it as an option on this one at all. It may be there, I just don't know where it is, but if I don't see it listed as an option, then I have serious doubts about its presence. And the same is true in this other calculator that I have. I don't really see where that is, so I don't think it has it. Unless it's a very specific like mode setting or something that we have to go into, and even then it's questionable what we could do with that. So something like this is where, you know, if we have you know what, doesn't even matter because my batteries are dead on that calculator. So what we would do here instead, since they still want us to calculate these values, is we'll just take the 0 and plug it in here, and we'll just do them one at a time. It takes a little bit longer, but we still are able to get the right answer. So if we did, let's see, if we plug in x equals 0, that means we have 0 squared plus 5 under our square root. So we'll do square root of 0 squared plus 5. So we get 2.24 if we round. And then we repeat that for 10, for 100, and for 1000. So for 10, for instance, we have our square root of 10 squared plus 5. And that gives us 10.25. And we would complete the other two the same way. So unless you know that you need a specific calculator that has all these different functions on it for your other class, some of the things mentioned in the worksheet are not particularly applicable to certain calculators. I don't know of any non-graphing calculator that has the table feature, but that doesn't mean it doesn't exist. Anyway, are there any questions on anything? Now, if you look again at the worksheet, after we get to these 34 problems, then you can see that we have the answers for each of these here. So you'll have the answers already. So the main thing is working through these problems and confirming that you were able to get the same answer. That's what I would like for you to work on for homework. Just go through these on your calculator and make sure you're able to use your calculator effectively enough where you can come up with these same answers. Okay? So, this is the only time that we're meeting this week. So our next class is Monday, and I hope you all have a good rest of the week, and I will talk to you then. Bye. Have a good day.